Alright, 0.2 approximating square roots. Objective. Students will be able to approximate an imperfect square root. Over here we have some perfect square roots for you, or perfect squares inside the square root symbol. Just kind of a reminder of what the square root symbol means. That's what I have this little image here for you to look at. So I want you to just, in your own words, what is a square root? How would you define a square root? I would take a look at this picture to kind of remind yourself. So go ahead and take a few minutes to answer that. You may want to pause the video, and then we'll be going on to the next thing. Alright, so let's start off by just evaluating these perfect square roots. So it says evaluate the square root. Well, 81 square root of 81. Well, remember that 81 is 9 squared. And so the square and the square root are opposite of each other. So the answer to this is 9. Now, sometimes you'll see people say like, oh, well, this could be this could equal 9 or negative 9. And that's somewhat true because negative 9 squared also equals 81. But generally, unless there's already a plus or a minus symbol in front of this, we're just always going to go with the positive square root. Okay, so if they would have started with something like this, then yeah, we're looking for negative 9. Or if it was solving an equation, then we would say, you know, if they said, hey, x equals square root of 81, then we could say, well, you know what, x could technically equal 9 or negative 9. And then we would have to test both answers to see which one's correct. But for the sake of today, don't worry about any of this. We'll get to all of this later. You've seen it before. It's not really that big a deal. All we're looking for today is the positive square root. So, what's 144? What's the square root of 144? I want you guys to go ahead and just try that real quick. See if you can figure out what two numbers, or what number when squared equals 144, and then you should be able to solve that. Okay, so hopefully you saw that this is the same thing as 12 squared. 144 is 12 squared, so you could have these square roots cancel each other out, and so your answer is simply 12. Great. Okay, so now I have a long explanation here. I typed it all up so that you guys could always have it to look back on. It's actually a really simple idea, but it's probably one you haven't heard of before, but I want you guys to be able to approximate square roots. It's all about number sense. So let me read it through with you guys and we'll talk about it. It says, what if the square root is not a perfect square root? For example, 71. That's not a perfect square root. That doesn't equal some nice, neat number like 9 or 12 above. It's going to be something more than 8, and I'll explain to you how I know that. So we recall that 8 squared is 64 and 9 squared is 81. Well, 71 is between 64 and 81. Therefore, the square root of 71 must be between 8 and 9. 8 and 9. But where is it exactly? Well, we can always find the decimal equivalent by just using a calculator, right? You guys could plug square root of 71 in your calculator and you'd get some decimal answer. So I want you to go ahead and try that. Just put square root 71 in your calculator and write down the decimal equivalent here. Okay, when I plugged it in my calculator, I got 8.426. I'm just going to do 4 decimal places, so 4261. Now, obviously, that number goes on and on and on forever. It's irrational. It just keeps going and going and going. So we can't actually know its exact value, but this is really close. So what if you don't have a calculator available? Well, there's an easy shortcut to approximate a square root. Just follow these steps. So I typed out these steps so you can have them, so you can go over them, and you can kind of see the process, but it's actually pretty simple. So the first step is to just find the two perfect squares that your square root must be between. So for example, we had 71. Well, 64 is the perfect square right before it, and 81 is right after it. So we know that it's somewhere between 8, because the square root of 64 is 8, and the square root of 81 is 9. So it's somewhere between 8 and 9. Which makes sense because, look, we found out the real answer is going to be 8.4 something. So we were right. It is 8 something. Okay. So since it's going to be at least 8, we can write 8 and then some fraction. Now, we don't know the numerator denominator yet, but I'm going to show you a really easy way to find the numerator and to find the denominator. So the real question is, what is that fraction? Okay, to find the numerator and denominator, use the difference of the perfect squares and your square root. For the numerator, subtract the radicand of your square root. Radicand is just a fancy word meaning the number inside your square root. By the previous perfect square. What I mean by previous perfect square is this perfect square right before it. So what does this mean? This is a lot of words, but it's really just a real simple idea. Here's the number 71. That's the number we're looking at. All we're going to do is, let's call that our x, and 64 is the perfect square right before it, so we're just going to do x minus a, or 71 minus 64. If we do 71 minus 64, that's a 7. So that's what our numerator is going to be. It's 7. Okay? And this is all just an approximation. It's not equal, but it's a really good approximation. Okay, so it's 7. And how do we find the denominator? For the denominator, subtract the next perfect square by the previous perfect square, meaning the next perfect square here was 81, and the previous perfect square was 64. So we would just do 81 minus 64. 81 minus 64 is 17. There's our denominator. So we can write it like so. I wrote it as a formula here. Maybe that's easier for some of you. Maybe that's more confusing. But it's just basically this. We got our 8. We knew that it was at least 8 because it was between 8 and 9. We knew that it was 7 because for a numerator, because we just did 71 minus 64, and that's 7. And for a denominator, we just did 81 minus 64, and that's 17. And we have an answer that is an approximation to the square root of x. So 8 and 7/17 is an approximation of the square root of 71. So now let's compare that with the decimal answer we had before. Right, we want to see how close were we. We know that square root of 71 is actually about 842615. So look, I even gave it a little bit more exact here. So, but what is 8 and 7/17? Well, to do this in your calculator, it's a little confusing. Everybody's got different calculators. So here's how I recommend doing it. Just start off by doing 7 divided by 17 in your calculator. So go ahead and just do that. 7 divided by 17. And I get a decimal that looks like 0.4117, okay? So when I just did 7 divided by 17, I got that equals about 4118. And I rounded because it's 4176, so I rounded 8. So, okay. Well, now all I have to do to really know what that is, I know that it's 8 and 7/17. So if 7/17 is 0.4118, I'm just going to do 8 plus 0.4118, which is 8.4118. So anyway, what we have here is an approximation. You can notice these two numbers are really close. Look, this is about 8.4. This is about 8.4. In fact, it's a little bit more than 8.4, and it's a little bit more than 8.4. So they're not exact. I know they're not exact, but it's a good approximation. This method is a good way to approximate square roots. So remember, this is for non-perfect squares. It's just a method for approximating these. I want you guys to practice doing this a couple times. I'm going to work through the first one with you, and then you guys can try the other two on your own. I'll put the answers up there. So let's talk about the square root of 40. We know that it is between, I'm just going to put little less than symbols here. It's going to be between 36 and 49 because these are the two perfect squares that I know of. And hopefully you do know your perfect squares really well. These are things that you should have learned already. Well, that means it's between 6 and 7. So we know that it's going to be 6 and something. Remember, to find out those something, we find the numerator first. It's 40 minus 36, the number inside our square root minus the previous perfect square. So 40 minus 36 is 4. And then we just do 49 minus 36. Well, 49 minus 36 is 13. So our approximation is about 6 and 4/13. So there we go. So once you try these other two on your own, I'll put the answers up there in just a little bit. I'd pause the video while you try it. Okay, hopefully you got something like this. I got that this was 9 and 18/19 approximately. Again, remember, these are just approximations. They're not exact. And this is 11 and 14/23, approximately 11 14/23. Now, how this is helpful is, like, I can tell that this is 9 and 18/19. This is really close to 10. And so this is like going to be like probably like 9.9 something. And this is a little bit more than half. So I don't know, maybe around 11.6 or so. I'm just kind of guesstimating here. But this is going to help us get a better approximation. We can tell if it's more than 11.5 or less than 11.5. So, and it's definitely more than 11.5. Okay, see you on the next video.